Hi guys, so we are live again. Let me share my screen. Yeah, so I will be trying to solve this problem first, then I'll be moving on to the system design study session because I haven't solved this today. I mean, I didn't get the time, I had to do some live scrolls and I had to cook, so it took a while. Anyways, let me start. We are given an array of indexes. We are given an array of non-negative integers. We are initially at position start of the start index of the array. So start is an index. We are given that whenever we are at index I, we can jump to I plus arr I or I minus arr I. We just need to tell if we can reach any index with value equal to 0. Okay. And notice that you cannot jump outside of the array. Seems pretty straightforward, to be honest. So what we are, this essentially boils down to a graph problem. So, but it is saying that from one, let's say you are at index 0, then you can go to 0 plus 4. 4, or in this case only 4 you can go. Uh, 1, 2, 3, 4. For from 4 you can go to uh, 3, 1, or yeah, from and from 1 you can go to index 3. I mean, I guess you got the point. So what we will do, we will construct a graph. By the way, if you don't want to construct a graph, then you can refer to this. Okay, some people are online. Let me write some hello message. Uh, so if you don't know about creating an adjacency array, then you can basically go check this. I'll add it in the comment. Yes, there are some people in the chat which are writing some nonsense, so we will ignore them. I'll add, I'll add it in the description. Yep. Anyways, let's try to. So, what we will do, we will iterate over this. Next will be I plus RRI, and previous will be I minus RRI. What you can do is if this next is greater than equal to 0 and then x is less than, it should be greater than equal to 0 always, because we are given that we cannot have negative integers, so we can avoid that check as well. By that, what I meant is we can just check, then we can go from I to, then we can move from I to next. uh, so oh my god. Okay, so there are some funny commenters in the chat. We will just ignore them. Yeah. So what I was saying is, this ARI cannot be greater than, cannot be less than 0. So we will not have a case where the next is less than 0. And same analogy can be applied here. Previously should be greater than this, and yeah. By the way, this will be a directed graph, because we are not given that we can go back from there as well. So this is a directed graph. Okay, never mind. So we can have this previous. Okay. Yeah. So We have a previously. Now what we can do is we can either run a BFS. So I hope you know how to run a BFS. If you do not know, I'll add that in the chat as well. This uh, I guess this should be okay. This is a video link, so I'll just add it. Okay, now we are starting from the index of start. Okay, again, just one more thing. We have to go to zero. So let's have a document. Right, something wrong. Let me have a map of targets because zero is our target value. So if ARRI is equal to zero, if this is yep, ARRI is equal to zero, then target I plus this is a good index that we want to reach. Might be that I'm giving a very small explanation, but I am assuming that you know all this small stuff. So what we can do is take this front and then mark it as visited, and we will be needing a visited array. And I'm sorry, we can go to uh, let's say this is node because I have a habit of writing this as IT. Okay. So then we can traverse this. If we haven't visited this stuff, we mark it as visited, and we can move this visited node from here. So just a brief thing: why am I marking visited at one here instead of here? So basically, what will happen is not in this case, but there can be stuff where this gets so we can have multiple entries for this ID. In this case we should not have it, but just for safety I'm doing it here. Push ID, and if we are reaching the target of, if this is a target value, then we can return true. Otherwise, if all the indexes are explored and we are not able to uh, find any good index, then return false. I guess this should be it. Let's see. Let's see. I don't have a compilation error. I did. Okay. 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 I targets. Okay. Should be targets. I mean, they don't give compilation error upfront. We have to run the code. So, okay. What did I miss again? Visited node is equal to, but this should be visited start. Targets of IT. Okay. Targets of node. Might be for the compilation error. I just wrote it fast. Yeah. I think this should be it. Let me try and submit it. Should not give any issue. Yeah, it is working, but it is very slow. Uh, we can optimize it a bit because we are using map of int of int. We can use vector of int of targets as well. I think this should be faster. Not that much. What else we can do? Let me add the anyways. But anyways, we solved the problem. I'm not sure why it is saying that we are only beating 6%. I thought we could have been beating much, but yeah. Anyway, there is your problem. This is very simple. I'll paste the submission. Can just give me a minute. Paste the submission link. So the code is very simple. But yeah, now let's move to the system design stuff, which is far more interesting than this. Let me open up my Excalibur. So, what I'll do is I'll open it here and just move this my other screen. So this was the. Is there a way to create a new? Never mind. We can write here. So this will be webcrawler implementation. So yesterday I felt I haven't give much detail about the functional and non-functional requirements. So today I'll try to do better. Right. Yes. So the question is design web crawler. So let's have it. I don't know how to make it large, but it should be. So just for the people who don't know what a web crawler is, a web crawler is a sort of bot which uh, runs. mm, I mean, I'll just copy the definition. Just give me a minute. So, web crawler is a bot or spider. It is commonly used by search engine to discover new or updated content. So, uh, nowadays, uh, AI also uses this for scrapping the data for LLM. So let me go through the problem statement first. So our main purpose is, I mean, I'm just reading the Alex Shoes book. So it is saying that the main purpose of our web crawler is search indexing, and yeah. So how many web pages do we want to crawl? Hmm, Second question. So we need to crawl 1 billion web pages. And or you could say we have to do it in 5 days. We have to, how much time we are given. Let's say we have 5 days. And you should also ask about uh, do we have some uh, uh, resources limit. So let's say we get the answer that we are free to use any resource we want. Okay, so now let's deep down. Let's go deep. Let me just open up my notes as well. Yes, now I have it open. So as we all know, we first starts with the function. Let's let's list down the functional requirement. Let's jot down if you want to use something. Jot down the functional requirement. Let me just delete grammar. This is causing me a lot of issues recently. Can I remove this? Let's jot down the functional requirement. So functional requirement is pretty straightforward. We will be giving a URL. We need to crawl it. Not one URL, but many URLs. URLs. We need to crawl these URLs, and second will be we need to store text data, and also we will be needing to store the metadata. Correct. Let me see if I have written all this. Yep. Yes, we have already discussed about the scope of the system. So scope the system is we have 1 billion web pages. So what we can given, yeah, 5 days to scrap. So let me make some assumption. Let's say one web page is approximately 2 MBs large. Let's say we are making this assumption. What more we can do is let me see. Yeah, resources we already have infinite resources. Now we can jot down the non-functional requirement from this. this. So our non-functional requirement will be first scalability. I guess the scalability is right. It's good because uh, we need to scale the system because there are so many web pages and we have only 5 days to scrap. Politeness. Politeness is nothing but you should not DDoS the website that you are crawling. What else? What else we can have? Let me think. Scalability, politeness, and we need efficient parsing of the that correct place. Yes. Yep. This is only that. Yes, one will be fault tolerant. I forgot about this. The system should be fault tolerant. Very important. By fault tolerant means there should not be a single point of failure. Yes. So we have gathered the requirement successfully. Let's now collect our core entities. Step 2 will be to collect our entities. A bit bigger. This this made everything bigger. I just wanted. Never mind. I just wanted to this to be big. Just give me a minute. Let me fix it. Control Z is not working for some reason. Control Z. Just want, I just want to have this. So this it is treating this as a single component. So let me write it here. So step 2 will be to collect core entities. Let's make it big. Yes, now we are able to do it. Yes, so what will be our core entities in this case? One I can think of is the URL, and they call it seed URL. One will be text data. One I was thinking is metadata. I mean, these three is the only one that I can think of. Uh, there will not be any images or all. Yeah, this is the only. These are only three entries. But in my notes, there is also one stuff like domain metadata. So let me break it down as URL metadata and domain metadata. I'll just write that. Okay. Okay. So step 3 will be to design API and interfaces. So in this step, we will have the input and output of the system. Which is pretty straightforward. Our input is URLs and our output is text and data. This text we should mainly focus on because this is used to train your LLM or any search engine optimization. Let me see what I have written. Yeah, it is the same. So we are doing good here. Let me make it a bit. So this will have some issues. So let me cut it, paste it here, and then make it large. Not this, but This is a bit annoying, but anyways, we don't have a choice. Cut this as well. Mm, yeah, so pretty annoying, but okay. So, and if this whole thing is now we are going to oh, why it is not getting selected. Never mind. This is but okay. I yes, yeah. Sorry for the trouble. Let's yeah, this is pretty straightforward. Now step 4 will be to identify the data flow of the system. Data flow of the system. Uh, so we will have a queue of seed URLs. Let's go step by step. Let me draw a box system. That will be much cooler. Let's see. Make it a bit larger. We will have a queue. We will have a crawler. This is just simply this will have the set of URLs. Wait. Then we need some. Then we will crawl the URL and get the HTML. Then what we need to do is pass this HTML. And then we need to store the text and metadata. So this is our basic flow of the system. This is also pretty straightforward. Make it a bit smaller, but yeah, anyways. This. So I guess you are getting what I'm saying. So yes, let's go down to fifth step. Step 5 will just be to list down the not list down the implement the functional requirement. We have already listed it down. Implement functional requirements. So what we have to do is have the minimal design ready. Implement function requirement, or this is called high level design. We have to implement a minimal design that is satisfying our core requirement. So we will have a queue. Let's say we need a queue. So let's say we are using So this somehow takes this space, but move this downwards. Yeah, let's say we have a queue here. Move it down. Why does it not work? Yes, now it should. Yeah, we have a queue here. So I am currently using uh, Amazon's SQS. I'll tell you why am I using this in a second, because you have to justify this as well. Why you are choosing this queue? I'll come back in a second here. But let's say we are using Amazon SQS here. Then what we need to do is we need to have some uh, web service. Mm, yes. Yeah, now it's better. Uh, I mean, I need to, I guess, improve my graph skills. But never mind. We will have this Amazon SQS here. Now, let's say we will have a uh, crawler service. Now, what it will do is it will uh, get the URL. This is get the URL from queue, fetch the URL. I mean, get the URL as well. I'll just try and get and fetch the URL from web. Then collect the HTML, parse this HTML into text data, and store it in a blob storage. Why blob storage? Blob storage because we just need a data storage, because we will not be querying this data as such. We will just be storing this data, and for that, blob storage is the best. Data storage, yes, and this blob storage will be Amazon S3. I guess we can use S3, or we can use Azure storage browser as well, whatever suits you better. I'll say this is. I'm not sure. Is it called S3? S3 buckets, I guess. S3 buckets or Azure blob storage, whatever seems good to you. Azure blob storage. And yeah, one more important thing I would like to mention is that yes, this fetching URL from web will be. Let's have a boundary first. How do you have a dotted line here? I don't know. Is it there a way to do it? Let's see. I want dotted lines. Mm, no, it is not allowing me to have. Yeah. So I guess now from this way I can. No, I don't. Let me see. Yeah, this is dotted, dashed. Yeah. So this is your system, but it will need to interact with the. I swear to God. Arey, why it is not, why it is not working? Yeah, never mind. Yes. I need to yes, change this. Yes, now we are back. Yes, this will interact with the domain name system to resolve this. Will interact with a DNS server to resolve where it needs to go, and then it will hit your web page. We will come there also in a second, but in this step we will just have a minimal design that can satisfy all our functional requirements. This is our page. Yes. So this is our minimal. Yeah. So yeah, I think this is more or less it. We have some water. Anyways, let me see if yeah one more important thing I uh, forgot to mention here is that this will extract the URLs that is nested inside the current URL that you are fetching. Store it back to queue. Correct. Just write queue. This is also do this. Now let me see if I can move it a bit. Yes. Now I can. Yeah. Yes. Yes. Let me see if my previous diagram was correct. Yes, it is correct. But just one thing we need to mention is that this will have seed URLs. Yes, so this is more or less it for the high level design that will satisfy all our uh, functional requirements. So now we will move to deep dives. Deep dive will include your identification of the bottlenecks, and we will try to make this better. Step 6 will be deep dives. Let me, there must be some commands to change it, but I don't know because I'm using a version, but I'm actually liking this thing. Yes, so let's say what requirements do we have? I think yes, scalability in that. Let me say, check. Uh, just give me a second. Yes. Okay. So one of the requirement is that our system should be fault tolerant. correct. This was our one of the non-functional requirement. But here, if you see, uh, this crawler service is doing a lot of stuff like getting the data and then get the data, get the URL, then fetch from the web, collect the HTML, and it is parsing this HTML into text data, then storing it in a blob storage, and again storing the newly nested URLs back to the queue, which is really a lot. So first of all, we can break this service into two. So let's start by breaking this stuff into two. So now what we can do is, let me take this freaking diagram, copy it, paste it here. Ah, never mind. Why my control Z does not work here? If anyone knows this, let me know why the hell this control Z does not work or something. But anyways, I think I'll draw it again. So now what we will have is a queue, Amazon SQS. We are essentially trying to break our crawler into two. So what this should do is, this will be our crawler service. Its main objective should only be get the URL, fetch the HTML, and store the HTML for processing. So now its job is only to fetch the HTML and store this HTML for processing. Uh, where can we store it? Yes, it's a good question. So since this raw HTML is also a very big data, we should store it. I'm sorry. We should store it in the S3 itself. The reason which I am giving is because this is some data that we will not be querying, because we do not have to run any complex query on it. So it will be better to store it in the S3 bucket, because that is cheaper for us. So just to give you a rough estimate, DynamoDB or Cosmos DB. So let's give an example of storage blob from MSFT and not DynamoDB, Cosmos DB from Microsoft. So the cost the cost of Cosmos DB is 10 times of storage blob. So, but anyways, we have unlimited resources. But if we can store money, then if we can save money, then we should. I think that is enough justification for it. Okay, so now this S3 bucket or Azure Blob Storage, whatever you are using, this will store HTML metadata. Now, uh, this will also store text data, but this will not come from here. Now, what this will do is, uh, this will also store the URL. This needs to be queried. So now we can use Cosmos DB or DynamoDB of S3 bucket. This is DynamoDB. We will require a database here because we need to query now. Let me just make it a bit better. So this DynamoDB will store the URL. This will have the ID, which is auto generated, and this will store the. I was thinking whether I should store the URL link or not. Uh, I mean, technically, I can save. So let me save the URL. Um Metadata, I think I can store. Let me check. Uh, but where was this thing? Yes, one more important thing is S3 link to HTML. Link to HTML. This generated, and we can have it. We can have this indexing here. I mentioned indexing last time as well for fast querying. My accent is a bit weird, but okay. And let's change. Let's leave it like this. We will change it according to our needs for now. I'm not able to think anything else to store here, but let's see. One more thing we will be needing. We will be needing called scroll. Scroll means that the metadata has been stored, and we will have sparse also. Metadata has been parsed, and what else we will be needing? Let me see. Did I added something else? No, not yet. Yes, I think this is it. We do not need much. Yes. I'm sorry. Yes. Also, this what will do, it will uh, push it push it down to push after successfully crawling and storing the metadata. This will push it down to the parsing queue, and what data we need? We need ID and S3 URL and S3 link. URL and S3 link. I'll tell you why we need this, because there will be a parsing service running. This parsing service job is to parse the data, store it in S3, push back the URLs that are nested back to queue. So, and mark is passed is passed as is, and I need to make two arrows also. Where are the arrows? This is how can I have a curved arrow? This is there. This is also not curved. I need curved arrow. Let me move it a bit, move it to sides. Here, move this thing. Move this. Mm, erase this. I think I should make my arrows a bit better. But anyway, I'll remove it. I'll use a curved arrow. Yes, this is much better. Ask you, yeah, I think you got the point what I was trying to do. Yes, now this has been, yeah, one more. Yes, this is done. Now, let's identify a bit more. Now, there are some issues. Yeah, one more arrow should be there before going deep. This will be, what is this? Push the extracted URL back to queue. Yeah, let me, yeah. So now now let's identify some few issues. So first of all, there is an issue that uh, I mean, I didn't draw a boundary. Let me draw first, and then explain. Sometimes, sometimes I feel this thing sucks, but never mind. It didn't selected everything, so I'll just do it again. Oh God, sometimes. Yes, now it should. So what I was trying to do is design a boundary. Anyways, it is not moving. Then I have to draw it like this. I mean, most of my time is going into designing this thing. But anyways, yes. So this is interacting with this crawler service will interact with these two. Copy and paste here. This thing never. This thing never works. I think I'll next time I'll use that thing. Uh, what is it called? I forgot its name. Why? Why is this thing testing my patience? Everything I guess now is selected. I can move. Yeah, now the big box is not selected. Wow. Again, let me try to select all. Yes, now I guess it is selected. Yes, finally. Yes, we were discussing about fault tolerance. Large. Yes. This I will make this extra large. Never mind. What I was saying is this Chotusa stuff needs to interact with DNS server. Why it is not? Why does it does not work? Yes. So dotted. Yes again. Yes. This stuff is needed to interact with the DNS system, and then crawl the web page. So what can happen is this web page may be down for some time, like maybe throwing a 500 or 400 error. So in that case, maybe throwing a 500 error, 429 error, this DNS, and this is what it is called, web page. So yeah, so this is a very uh, I would say common scenario that this web page might be down. So in that case, you will have to implement a retry mechanism. So there is two ways to implement retry. One you can have directly at the service layer, but we typically don't do it. The reason is, I mean, in some languages it may this may be a bit complex to implement. The reason being, it may so the crawler may sit idle for some time. I mean, the crawler is mostly spending its time waiting for the exponential backup to uh, resolve. So the resources will get wasted. So that's why we have we have used Amazon SQS, because this gives you uh, retry over the top. I mean, you can have a retry mechanism directly built on this Amazon SQS via exponential backoff. Again, two problems will get solved, but your queue will be doing more than one thing. But anyways, I am choosing to use this, so we can have a exponential backoff. Yes. You can choose to have exponential backoff here on the queue itself. Now, there is one more issue, that you do not want to uh, retry infinitum. So maybe it is a case that this web page has already been moved or removed, or it is always showing 500. Then you will so for resolving this scenario, you have to set up a, what you say, uh, a hard limit on your exponential backoff. I mean, how many times you want to retry. So I am choosing it to be 5. in my case 5 retries. Then even if after 5 retries it is not able to process, then the message will be moved to a dead letter queue. So dead letter queue is just that we tried our best, but still we were unable to process the request. So on fifth, on after 5 retries, we will after 5 retries move to dead letter queue. Okay, simple. Okay, this is done. Now what else we can do? Let me see. This dead letter queue is done. uh, any more ideas we have? Yeah, obviously we will not try infinitely. Yes. One important thing is you can mention that this Amazon SQS uses visibility time, so that no more than one worker can process an event. This is something that you can mention. So just for your knowledge, if you are using Kafka, that uses a concept on consumer group and partition groups. So it partitions the events itself, so that these consumer will process from this only. So that's how they are able to avoid multiple process of the same event. In this case, it will not cause any issue because this will be idempotent only, but our resources will get wasted if you are getting my point. Let me see if I am not missing something. Yep. So this arrow we have mentioned the HTML. I don't know how to do it better. How to do in a better way. Uh, can I change its orientation? Yes, I can. Save the HTML and update metadata. Metadata. Let me know it's not bit vague. I mean, you are able to get what this component is doing. Yes, so this is done. Fault tolerance, I guess, will be. And what if the parsing queue fails? So in most of the this implementation of the web crawler, you will have a scheduler also. So this scheduler does a lot of stuff for you, like not all the web pages are important enough to get queried. I mean, carries a rich data. So you can have a for pushing the extracted URL back. This you can use a scheduler. So here you can have a scheduler. This is optional. Maybe I'll have it in the future. Let me see if I have something regarding this. Hmm, let me check. This I have. I do not have any architecture. yes, we can use a priority queue here, and we can use a crawl scheduler. I mean, in between this, we can have a scheduler which is intelligent enough to give us what we have to process. Yes, now to let's move to politeness. Yes, next to politeness, like this. Let me check what else we are reading. What else? Yes, we have a rate limiter, and then okay, scaling. Next will be politeness. Politeness. So this politeness means that there is a robot.txt file which tells txt file which will have a domain list that are not that we cannot disallow. We have a disallow list. The pages we are not allowed to view, and there is also one. What is it? Yes, scroll delay. Important. This scroll delay. This is to prevent. This is to prevent DDoS of the website. And third is let me see, is it user agent? Let me check. Let me check. Crawl. Yes, one is user agent, which means which mean which user agent we need to allow the crawler root. Okay, this is we have, so we need to maintain. Let me see, should I maintain? I mean, I'll check whether I should store it in this URL table only, or should I make a different table. For this, what do you say, domain different or URL. I mean, I would personally want to have two. Yes. Can have. Okay, so yes, it is also suggesting to use a different table. So yes, let's make a different table for this, which is called domain, which will have domain name, which will have disallow, which will have. I mean, we need don't need to. Just give me a second. disallow, this will be a list of variables, and we will have crawl delay, we will have last crawl time. Yes. Okay. Yes, these four should be it, and let me see. Yes. Yeah, one more thing. User agent. Now our flow will be for a domain. We will check its last crawl time, and after if it is less than date dot now, we will set the visibility time to crawl delay. Sorry, date dot now, not date dot now. Yeah, I mean we can calculate based on, this should be last crawl time of last crawl time plus crawl delay is greater than date dot now, then set the visible time of to crawl delay plus last crawl time. The difference to time to the difference, it needs to wait or not throttling. This will be I guess last crawl time plus crawl delay itself. I mean 30, and we are saying that we need to 40, then we need to wait. Yes, which is just be the difference between these two. Let me just check one more time. Yes, so this will help. Okay. Yes, this will have a click because we need to have some. I mean, I will probably not do it in an interview, but for the sake of doing it, let's have this foreign key here. Which is foreign key. Yes. Okay. This is done. I guess this is yes. Yes, so we will have one more component here, which will be our uh, rate limiter, because we need to save the state so that we do not exceed. So we can use a Redis instance for our rate limiter. This rate limiter, remember this rate limiter is for this due to the robot.txt rate limiter. So that this purpose is we should not let me should not DDoS the, the domain itself. So I was just doing chat GPT, so it was saying that. So basically, this last call time should be here, but in our requirements, we only need to implement it for 5 days. We do not have to uh, write the last crawl time here also, because I mean we will not be having the freshness issues that we have stale data. We let's I mean this should be discussed with the interviewer, then only we will be storing it in our URL. But okay, I guess this is clear enough. Let me just move forward. Okay, now yes, now the third will be scalability and efficiency. So we need to crawl 1 billion web pages in 5 days. 1 billion is 10 to the power 9, and there are approximately 10 to the power 6 seconds in a day. In a day, then in 1 second, we need to process 1000 pages. So 1000 per second is our limit, is our desired value to process. Correct. Now, what we can see is uh, one web page is almost around 2 megapixel, 2 megabytes. So we will have 2000 megabytes per second. Someone is in the chat again. Yes, so I was saying we will have 2000 megabytes per second, which is correct. Yes, 2 GB per second. So, second. Okay, it's the second. Yes. It's, yeah, we have to do in a day, and we have to do it in 5 days. So this will be like I made a mistake. So in a day, and we have 5 days. Yes, so this will be Yes, sir. Let me see. 1 billion is to 1 billion. 10 to the power 9. Yes, 10 to the power 9, and we have 5 days. So this will be, this will be, yes, let me have it again. 1 billion pages, which is 10 to the power 9 web pages. We have 5 days. In one day, we have to the power 5 seconds. My bad, 10 to the power 5 seconds, correct. And we have 5 days. So this will be 10 to the power 9 divided by 5 divided by 10 to the power 5. This comes out to be 2000 web pages per second. Okay, we need to process 2000 web pages per second. Now, yes, so this 2000, and we are assuming that one web page is approximately 2 MBs. Ps. So this will give us 4000 MB per second. Let's double it down. Let's make it 8000 MB per second. Let's assume it. This is 8000 MB per second to process. How many? Let's see. Let's check your MB per second. It is 8 GB per second, which is approximately 64 gigabits per second. So 8 GB per second, which will be approximately 64 gigabits per second. So this is the this at least we need to choose a machine. At least we need to choose a machine with this throughput. I don't know. Let me check which machine can be 64 GB per second throughput. Which is your machine can give it? I mean, we can search for. So it is saying that HP V4 machine can give it. So 1 HP V4 we can use for deployment of server. Standard SPO series should work. Okay, nice. So I mean, this can be decided then. So we are choosing standard HPV4 series, and we can have two servers. This will be the for the crawler service, correct? This one. So we have choosing two instances based on calculation. Now this parsing service, which should have a automated scaling based on the parsing queue. uh, Automated scaling based on the parsing key. Yes, correct. Okay, so this is also done. Now let's talk about the more bottlenecks. So one bottleneck is duplicate data. So this we can avoid use by hashing the content of the HTML. Why HTML? Because we don't want to reach our parser if the data is duplicated. The data is duplicated. This so we will store where we can store where we can store the content hash here, and we can make it a secondary index. I guess this is what it is called, secondary index. So secondary index, we can do this secondary global index. I guess I'm not sure why it is, but it is called, but let's say index, secondary indexing, whatever, to have a fast query. And we can use a, so now every time you do not want to uh, query your database, obviously, so you can have a redis set, redis hash set, I guess it is called, in front of your yes. So why we are, so there is also, we can also choose bloom filter, but if you have a space constraint, then choose bloom filter. So bloom filter gives definite no, but can give false positive. So let's say our hash content is equal to 20 bytes, and we have 1 billion web pages. Well, this will be 1020 into 10 to the power 9 bytes. Let's see how many gigabytes it have. 20 into 10 to the power 9 bytes. 20 gigabytes. So this comes out to be 20 gigabytes. I guess one Redis instance gives you 256 GB. So it's better to use Redis, and you can use the same Redis which you are using for rate limiting itself. Rate limiter plus Redis limiter and Redis hash set. Set for duplicate content. So this can be avoided now, and this happens a lot. One more thing I can think of is I had it in mind. I had it in mind. Uh, the what was it? I forgot. But yeah, depth of a web page. So depth can be indefinite for a web page, and most of it do not have a valuable data. So we can maintain. My phone is ringing. Let me. Yes. So yeah. So what I was saying is we can maintain a depth of 5. I mean this. You can ask your interviewer how much depth that you want to go, and one more bottleneck is I can see is avoiding duplicate URLs. For this also, you can use a hash set. You can use a hash set or something that is, or you can use a blue filter. The blue filter, but I mean blue filter does not make much sense. So just use the disk set here. Yeah, one more important bottleneck is DNS. DNS itself can be your bottleneck because DNS may limit you. So what you can do is have cached, and what you can do is have it cached, or you can use multiple DNS providers. Yep. So this essentially should be it. Let me see. Yeah. So you can optionally have a scheduler here. I'll just write it. This is optional. Let's have it. Let me see how much points am I getting. Let's squeeze it down a bit. Copy as PNG. Let's see how much it is giving me. Okay, so this is good enough for SDE2. Okay, so it is saying to chart it by domains, but I don't know it. Hmm, Okay, so this gave me a word it selected. Okay, so it is saying that I can get selected with this, then this is good enough for me for now. It is saying that we need to emphasize more on this scheduler. Uh, yep, I can do it. And okay, sure. Yep, this is it for today. Yep, see you guys again. Bye bye.